Hi everyone, welcome to another tutorial. In today's tutorial, I'm going to show you how to create a population density map from the data which is downloaded from internet for free, and how to do this using Python scripts which are sort of mainly developed around the Geopandas Python library. So let's get started, and first of all I would like to show you the websites which I'm going to acquire this data. You see this website named citypopulation.de, and I have navigated to the section of Nepal because that's the country that I'm going to use for this example. And over here you can see actually some information about the population census which has been carried out in year 2001 and then year 2011. So most probably I might use the latest data, which is 2011 data, for this exercise. So, and here you can see actually the data has been grouped by the name of each district. So I'm going to use a script to sort of retrieve this information directly from the website into a pandas data frame. And the GIS data that I'm going to use will be downloaded from this Diva GIS website. And as you can see over here, I have selected the country Nepal, and I'll be downloading the administrative areas, specifically the districts. So as you can see, I'm using Spyder as my code editor, and I hope that you have already installed Spyder by now if you have been following my tutorials for quite some time. In case if you do not know how to install Spyder and configure it through the installation of Anaconda distribution, check this tutorial out. I'll put the link down in the description below. So once you're here, the very first thing that I would do is I would just navigate to my folder which I'm going to work in. That one you can select it from here, and once you are inside that folder, just make sure that you're actually in the File Explorer tab over here. You can simply right click over here and then create a new module, and I'm going to name this module as population density nepal.py. First I'm going to import the main libraries which we are going to require in order to complete this tutorial. So there's going to be actually 3 libraries. The first one is pandas. I'm going to import it as PD, and the second library is, maybe I'll increase the size of the font so it'll be easily visible for you guys. The second library that I'm going to import is Geopandas. I'm going to import it as GPD. And the third one is just for basic plotting exercises. I'm going to import the matplotlib library as PLT. Once you have done this, you can just simply hit F5 just to run the command to make sure that your code is your libraries got imported without any issue. And alright, now actually it's one functionality of pandas that you can directly read stuff from the internet, I mean from a website. So you can actually use the command pandas.read.html in order to do that. So that's what I'm going to do right now, and I'm going to create a variable called data, and we can use this data equals pd dot read html, and over here what you need to do is you have to specify the web address. So I can just simply go over here, copy this, and paste it over here. Right. Just make sure that you have the complete web address which includes this HTTP colon part as well. And after that you can just simply run. And now first of all, now before anything, I'll just let you have a look at this table again. You can see the structure of the table. It has 5 different columns, and then it has this multiple number of rows. So once we do this, actually this data sort of get imported and saved into this variable called data. Now you can see that we have a variable called data over here, but then it's of the type list. And if I open this one, it's just actually not going to show me any specific data, because everything is actually sort of contained in a list. So what we need to do is we need to sort of extract this data from this list and save it into another variable in the form of a pandas data frame. So I'm just going to use a simple for loop in order to do that. So we can say something like for population data in data. Now this data refers to the same variable over here. Then I'm simply asking it to print the data, print the population data, and then we can run this one and see what happens. Alright, now you can see that we created another variable called population data, and then that population data belongs to the type of data frame. So if I open this one, now you can see that we sort of retrieve the data, maybe not perfectly, but we sort of managed to retrieve the data from the website into a pandas, into a data frame, as you can see over here. If I compare this side by side, you can see that we have this name column, we have the native status, population census, and then there is another column which is called unnamed 5, which I cannot see over here. So it's quite natural that this kind of unwanted information will sort of appear in your final data frame. So it's up to us to sort of clean this out and only take the relevant parts which are necessary to us. So the next thing that I'm going to do is that, since I'm going to actually run this code at multiple locations, since I'm doing a tutorial, I'll be running this code again and again at every step that I'm going to demonstrate. So I don't want to have the small lag that I observe whenever I actually call the data directly from this website. So instead, what I'm going to do is I'm just going to save this information into a table into Excel file, and then whenever I run the command, I'll actually directly call the information directly from that Excel file rather than calling them from this website. Let's save this population data into Excel file. How do we do that? We can just simply say population data dot to. Make sure you put the R sign over here so that it recognizes this to be a path instead of something else. And I'll name this as population pop xlsx. Right, now I can run the command. Now if I navigate to the folder, you can see that we already created this Excel file called pop, P-O-P, which basically looks something like this. Alright, so we'll close this file. And now, since I'm not going to actually import this stuff anymore, I'm just going to comment this out, and in the code, this code will not be actually actively running. So I'll just put a comment over here. And you can just highlight the whole thing and then press Ctrl+1 to either make it active, or you can press Ctrl+1 again to sort of comment that out again so that when we run the command, these lines will sort of be ignored. So now I'm going to actually directly read the data that we downloaded from the Excel file, and I'm going to save that into a variable called population data, which is equal to pd read Excel. That's exactly going to be this one. Alright, now we can run. Alright, now if I open this population data, you can even visually see it over here, or if not, you can just even come to your console and type population data, and then you can sort of get an idea about the elements. And if you like to just see the columns, it'll show you actually how many columns are there and then what the names of those columns are. But since we are using Spyder, actually that's one of the benefits that we have a very nice GUI, so we can visually see what the columns over here are. So out of these columns, actually I'm only interested in these three columns: the name, the status, and the population census of this last year of 2011. So I'm just going to select only these three columns and then neglect the other columns. So we can do that just by saying population data equals population data, and you put double brackets over here because you are selecting more than one column. If you were to select only one column, just one square bracket would be sufficient. So in this case, the names of the columns are name. Just going to copy it from here. The second column was status, which actually had the information explaining whether it was a district or it was another element. And then I'm also going to select this population census of 2011 column. Alright, now we can run the command again. Now if I open this population data, you'll see that we sort of stripped out the unwanted information. So that's how we do that. I'm also actually, just for my own convenience, I'm going to rename rename the headings of these columns. Over here it shows the population census, but the names, the headings of the column seems a bit crowded to me, so I'm just going to show you how to rename the columns. So we can say that population data dot rename columns equal. Here we put the original name of the column, which is this, and after the colon we can specify the name of the column which we would like this original column to have, so that basically whatever we type here or over here will supersede this name. So I'm just going to call it as population, nothing fancy. Alright, now that we can run this one. And now if I open this, you can see that actually it still did not get changed, because this is sort of a temporary call that we do. So if you want this call to be a permanent one, you actually have to specify here in place and make that to be true. And now if you run and if you check, you can see that actually it got changed over here already. So that's how we do it. And then I'm going to show you how to filter rows by value. Now what do I mean by this? if you open this variable, you can see that under status there are these districts, there are these rural municipalities, and then there are these national parks, but I'm only interested in actually isolating the districts, and I'm just sort of going to filter everything out based on the value of this column. That's the value that I'm referring to is actually district. So what I'm going to do is basically I'm just going to extract every row along with the name and the population which corresponds to a district, because that's what I'm interested in. I'm not interested in the municipalities or rural municipalities. So you can actually do a simple filter operation from here in this way. Population data, that's equal to population data, and if I open over here, you can see that the column name of the column is status, so that goes in here, and you would like that status to be filtered based on the value which is called district. Basically what I mean by value is over here the value is basically a string. What that string refers to over here is actually district. Change the bracket to be over here, and let's run this command. And now you can see that we sort of isolated the information of only the districts. You see, now you can even type population data over here and see there are 77 districts. I'm not so sure about this, whether there are actually 77 districts in Nepal or not, but that's what the information gave us when we sort of isolated the 77 districts over here. Alright, so that worked quite alright. And next I'm going to actually show you how to create an empty column. I'm going to name that as districts2, and for the time being I'm just going to leave it as a null string. Now there's a reason why I would do this. I'll explain to you in a minute. Now you can see that we created this empty column called districts2. The reason why I would like to do this is actually, you see that, so to me it appears like first they have indicated how these characters actually should be spelled in their own native language, but then they have actually tried to put these accent marks just to make it easier for the reader to precisely pronounce it. But then right beside it, within square brackets, they also have actually indicated the English name. So the first one is actually going to be of no use for me, because later I'm going to merge this data along with the GIS data that we downloaded from this from the Diva GIS website, and the names of the districts are actually going to be in English rather than it being in this particular format, which is sort of unique to this website from what I see. So now what I'm going to do is actually I'm just going to run a for loop through each of these districts and identify the cases where they have this kind of specially structured characters. And if there is a setting like this, I'm just going to extract only the English word and then copy it over here. And if it's just the English word over here, for example, you see over here there is no separate word which expresses how to sort of pronounce it in their own language. So in a case like this, I would just directly copy this into this cell. But in a case like this, I would actually just go for the thing which is inside the bracket and then copy it over here, because to me it seems like that's how you would actually write that name in English rather than employing these special characters. So there are a couple of tricks that we might need to do in order to do that. So what I'm going to do is I'm just going to run a simple for loop. And that for loop will actually work for this population data. And I'm going to iterate through the rows. Alright, so the way to explain this would be actually when you're iterating through the rows, what I'm going to do first is actually to check in each row whether it contains this the beginning of the square bracket and the ending of the square bracket. As you can see that structure is quite unique for every case where you find the names in doubles. So that's actually one criteria to identify whether you need to sort of look inside this bracket or not, just by finding out whether it has the two brackets or not. So a way to do this is actually using a conditional statement. So I'm saying that if it contains the starting bracket and this ending bracket in and we are going to check that inside this name in this name column. So if this conditional statement is true, then over here we try to write what sort of things we would like for the program to execute. So I'll just show you a quick example over here. For example, if I create a variable called a and then I give a variable called geodelta to that, it's a string, it's a temporary string. So for example, if I want to identify whether this capital D is in this geodelta string, one way to do the check would be to do something like this. I would say that capital G in A, and you can see that it gave us a Boolean value which is true because this capital G is actually inside this A string. And also there's a way to actually identify the location of the string based on the index number. So you can actually use something called a.find, and then over here we can specify which string you would like to find. For example, in here if I type capital G, it will return me a value of 0. That means in this string this capital G is actually located at the 0th location. Now if I type over here, instead of capital G, let's say if I type L, you can see that it gives me the location number in terms of the index value, and that's going to be 0, 1, 2, 3, 4, 5. The fifth letter is actually the L letter. So I'm just going to use the same technique just in order to identify where exactly this where exactly the location of these two brackets are. So I'm just going to write that as start index. That's going to be row name, and whenever I specify name, that means actually we are already somewhere over here, and then we can just type find the location of this of the place where we open the bracket. So for example over here, that location is over here, and then I'm just going to put another variable called end index, and that ending index is going to be dot find Alright, get rid of this. Okay, now if I run this command, you will see that there's this new variable called starting index, and there's this new variable called end index. This one is 9, this one is 19. And as you can see over here, now we ran through a loop. Alright, now coming back to this example which I showed you over here, if I actually would like to have this whole string generated again, I can say something like a followed by the specification of my starting index, and it's 0, 1, 2, 3, 4, 5, 6, 7. You can see that actually we get everything except for the last letter. So if you actually would like to have the whole string printed over here, even though your corresponding identification over here, that is the index number, is 7, you still have to actually jump one ahead, and you have to specify this as 0 to 8, which will actually generate the full name. So I'm just going to employ the same concept over here, and I'm just going to say something like this: population data index districts 2. That's where I'm going to actually input this data into, and that's going to be equal to population data dot log. It's going to be index followed by name. And now here, when I have to specify the index, my start index is actually going to be the starting index without any issue, and this is going to be end index plus 1. Alright, now let's run this command and see what happens. Open up population data, and you see that we sort of managed to extract everything inside the square brackets over here. So now you still see actually we don't need to actually have these square brackets over here. So I'm just going to make a slight change in the way we acquire the data over here. So instead of actually starting exactly from the square bracket, we can sort of jump one ahead and start precisely from the correct word. And the ending index, we don't need to sort of specify we can keep this as the index of the square bracket, so that it will actually reduce it down by 1 unit and give us the correct name. So for example, if I run this now, we can see that it accurately extracted this data, which stays over here, into this. But you still see actually some gaps over here, because now this command was this statement was actually written only if there were these brackets in the rows. But then for the cases where the brackets are not to be found, you see that it does nothing. So we can just simply put an else statement and say that population data dot log index districts2, that's going to be equal to over here. It's just name without any specification of specified range of characters or anything like that. So we just run this command, and now if I open this, you can see that actually we sort of stripped out the unwanted parts over here and then copied the exact English name into this new column called districts2. So now actually there's no even reason to have this name column, so I'm just going to get rid of it later. And even this district actually just shows that it's a district, so I'm just going to create a new, I'm just going to modify this variable to have only this population and then this districts2 columns. So we already know how to do that. First we specify the names of the columns. One is population, the other one is districts2. Just make sure that you have an additional bracket. Alright, now you can run and see that we only isolated these, and then I'm just also going to sort of rename this districts2 into something called district. Well, these steps are actually not really essential, it's just for your own preference. Columns which are equal to, in this case it's just one column, that shall be renamed as district. Right, now you can run this, and sorry, we have to put in place equals true. Alright, now should be fine. Okay, now you can see that we have two columns. One is district and the other one is the population corresponds to that district. Alright, so I'm going to actually split this video into a couple of segments just to not make one very long video. So in the next section, I will show you how to import the shapefile data and how to sort of utilize this information that we sort of derived into generate a population density map in Python itself using Geopandas. So just check the second part of the video for the continuation from here.